All right, let's just dive right in. Today, we're going to take a hard look at the very fabric of our reality. I mean, we all think of space and time as these absolute fundamental things, right? But what if? What if they're not? What if they're just an illusion? Shadows of something much, much deeper. That's what we're going to explore. This quote right here from way back in 1908, it perfectly sets the stage for our whole conversation. Think about it. He's saying that space and time, by themselves, are just shadows. That's a pretty radical idea, right? He's basically telling us that our most basic, everyday experience of the world is just plain wrong. And this was really the first major clue that the universe is, well, a whole lot weirder than we could have imagined. Okay, so to really get where we're headed, we have to go back in time a bit. We need to understand the universe we thought we lived in. For hundreds of years, physicists had this really neat, tidy picture of the cosmos, a real clockwork universe. Everything made sense. But there was this one single, stubborn little fact that just didn't fit. And it was about to break everything.
So on one side, you've got Newton's universe. And honestly, it just makes sense, doesn't it? You've got one universal clock ticking away at the same rate for absolutely everyone. You've got space, this big fixed 3D box where all the action happens, and gravity, just a simple force pulling stuff together. Easy. But then physics just slammed into a brick wall. The math for light said its speed was always the same, which sounds fine, until you ask, the same relative to what? This was the killer problem. The idea that light speed is constant for everybody, no matter how fast they're going, well, that just completely shatters all the old rules of adding speeds together. Right, so the going theory was that light had to be waving through some kind of invisible cosmic jello called the ether. It made sense. So these two guys, Michelson and Morley, they set up this really clever experiment to try and feel the wind from this ether as the Earth whizzed through it. And what did they find? Absolutely nothing. Zip. Nada. No wind. No ether. It turned out to be one of the most important failures in the history of science, because the only conclusion left was totally bizarre. The speed of light is just the speed of light. For everyone, always. And that, right there, set the stage for a total revolution. And this is where our main character enters the story, a young patent clerk named Albert Einstein. See, while everyone else was trying to find clever ways to patch up the old, broken theories, Einstein did something completely different. He just accepted it. He said, okay, what if the speed of light is constant? Let's just assume that's true. And then he asked the big question. If that's true, what else has to give? The answer was going to completely reinvent reality as we know it. So, to keep that speed of light constant for everyone, something fundamental had to break. And that something was space and time themselves. Yeah, Einstein realized that if you're moving really, really fast, your clock literally ticks slower than mine, and the ruler you're holding actually gets shorter in the direction you're moving. And maybe the weirdest one of all, the whole concept of right now just goes out the window. Two things that happen at the exact same time for me could happen at different times for you. It's wild. Space and time aren't this rigid backdrop we thought they were. They're stretchy, they're relative. And look, this isn't just some wacky thought experiment. This is real, measurable stuff. For example, there are these tiny particles called muons that are created way up in our atmosphere. They have super short lifespans, so they should all decay long before they ever reach the ground. But we see them. Why? Because they're moving so fast that their time literally slows down, giving them enough life to make the journey. And get this, the GPS in your phone, the one you use every day, it has to be corrected for these relativistic effects every single day. If it didn't, it would be off by miles within a day. So yeah, this isn't philosophy class. This is engineering. But Einstein wasn't done. Oh no. After rewriting space and time, he set his sights on gravity. And this quote from the physicist John Wheeler just nails his new idea. He said, "Space-time tells matter how to move. Matter tells space-time how to curve." So gravity isn't a force like a rope pulling on things. Not at all. It's just the shape of space-time. Big things like the sun literally create a dent or curve in the fabric of space-time, and planets like Earth are just rolling along the straightest possible path in that curved space. They think they're going straight, but the space itself is bent. And the predictive power of this theory, it's just unbelievable.
For more than a century now, every single test we've been able to dream up, general relativity has passed with flying colors. I mean, from predicting these tiny, weird wobbles in Mercury's orbit all the way to us actually taking a picture of a black hole's shadow, Einstein's math has described it all, flawlessly.
Okay, so we've established that the universe is this weird, stretchy, relativistic place. It's a fact. But now we get to the real heart of the matter. The central question we're asking today, which is, why? Why on earth is the universe built like this? And here's the crucial thing to understand. Einstein's relativity, both special and general, is a perfect description of the rules of the game. It tells us how everything works with mind-boggling precision. But what it doesn't do is tell us why those are the rules. It's like having the perfect instruction manual for a super complex machine, but you have no idea why the designer chose to build it that way.
I mean, really, why should the speed of light be the ultimate cosmic speed limit? Why that number? And why should gravity, this thing that holds us to the Earth, just be geometry? It's bizarre when you think about it. These are the why questions that have kept physicists up at night for 100 years. And they hint that maybe, just maybe, relativity itself isn't the bottom floor. Maybe it's a clue, pointing down to something even deeper.
And that, my friends, brings us to the really radical new idea we're digging into today. What if space-time isn't fundamental? What if it's not the bedrock of reality? What if, and all the rules of relativity, are just emergent phenomena? Something that arises from a much deeper, more fundamental code, a code written in the language of pure information.
Okay, let's try to unpack that, because it's a big one. So imagine for a second that reality isn't made of stuff in space and time. Instead, it's made of bits of information, kind of like a giant holographic screen. Now, in this picture, my personal experience of time passing, 1 second after another, that's not some fundamental universal thing. It's just an effect that emerges from the information being processed on my little corner of that holographic screen. Time isn't a river we all float down together. It's a personal, local thing for each of us. And here is the big reveal, the aha moment. If my reality emerges from my patch of this information screen and your reality emerges from your patch, how do we make sure our two views of the universe don't contradict each other? How do we make them consistent? Well, it turns out that the only mathematical rules that let you do that, the only way to logically mesh all these different perspectives together, is the math of special relativity. Time dilation, length contraction, all of it. So let that sink in. This idea completely flips things around. The laws of relativity aren't some random physical rules that the universe just happens to follow. No, they are the logical, totally unavoidable result of living in a universe where no one has a special privileged viewpoint. It's like a democracy of observers. And in a universe without a single God's eye view, relativity is simply the price of admission. It's the only way it could work. Now, this is way more than just a cool philosophical reinterpretation of Einstein. Because if this is right, if space-time is just an emergent illusion, this new way of thinking might actually solve some of the biggest, most frustrating puzzles in all of physics. So what does it unlock? Well, get this. First, all that bizarre quantum weirdness that happens at the tiniest possible scales? Maybe that's not weirdness at all. Maybe that's just the point where our smooth illusion of space-time shatters and we're starting to see the actual pixels of reality underneath. And the black hole information paradox? The problem of where information goes when it falls in? Poof, gone. The information never really falls in, it just gets smeared out on that deeper holographic screen. And even the biggest embarrassment in physics, the cosmological constant, the energy of empty space, its value might be naturally explained by the very structure of this informational screen. It just solves so much. But honestly, here's the most mind-blowing payoff. We've been hunting for decades for some mysterious invisible particle called dark matter to explain why galaxies are spinning way too fast. This new framework offers a totally different and frankly wild alternative. What if there's no dark matter? What if what we're seeing is just a kind of glitch, a tiny imperfection in the underlying informational code that makes it look like there's extra gravity there when there isn't? And again, this isn't just some vague, hand-wavy idea. The theory actually spits out a hard number. It predicts a specific value for this weird extra acceleration, and it derives that number from the cosmological constant we just talked about. And the crazy part? The predicted number is an almost perfect match for the strange acceleration we actually see in thousands of galaxies. It could be a direct link between the largest structures in the universe and the fundamental code of reality itself. It's just, wow. So, what a journey, right? We've gone from Newton's simple clockwork universe to Einstein's mind-bending, stretchy space-time, and now all the way to a reality that might be nothing but pure information at its core. This new idea suggests that relativity itself, the cornerstone of modern physics, isn't fundamental. It's just an illusion that emerges from a deeper code. So we just might, finally have an origin story for space and time. But that just leaves us hanging with one final, massive question to chew on. If space and time are the illusion, then what in the world is matter?